This presentation will analyze the microcontroller hardware and software design required to create a simple aeronautical control system utilizing sensory input and servo output. Specifically, an inertial measurement unit will be used to autonomously control the pitch of a mock aircraft in order to keep the aircraft's nose level with the horizon.
Hello, again my name is Christopher Albright, and here's my project. I kept it as simple as possible to demonstrate my stated goal. I'll go over the components briefly. Here we have the Arduino Uno microcontroller. Here is the Adafruit 9-axis absolute orientation sensor, or inertial motion unit. And I also have a pair of servos. I used a breadboard to connect all the components. The IMU sends spatial input to the microcontroller, and the microcontroller then sends outputs to the two servos independently. I have a capacitor in parallel with each of the servos to help with power. Let's get started. Powering it up. Here the IMU is taking initial measurements, and we can now see that the microcontroller is sending outputs to the servos, keeping it in line with that initial condition. And as our sample aircraft begins to move, we can see that the rudders will try to keep the aircraft level. The IMU detects the motion, sends a signal to the microcontroller, and through the program I wrote, the microcontroller sends the correct commands to the servos to orient the control surfaces and keep it level. As we can see, it works just fine. And that's it. Thank you.